Welcome to The Explainer. There are certain things that just separate good developers from great ones. And today, we're diving deep into one of them, design patterns. We're going to crack the code on these powerful blueprints so you can start writing way cleaner, way more professional code like right now. So yeah, let's get into it.
But first, let's start with a question I think we've all asked ourselves at some point, probably staring at a screen at 2 a.m. Why is it that our code, which starts out so clean and elegant, so often turns into this tangled, messy web that's an absolute nightmare to change? Come on, you know you've been there.
Well, the answer, and this is the key, isn't really about what the code does. It's about how it's all put together. It's about the architecture, the very bones of your application. If you get that structure wrong from the start, complexity is pretty much guaranteed down the line. And this is exactly where design patterns come to the rescue. Now, don't think of these as some kind of rigid academic rules you have to follow. No, think of them as elegant, battle-tested blueprints. They're basically the collected wisdom of countless developers who ran into these exact same problems and figured out a really, really smart way to solve them.
So, to really appreciate just how brilliant these solutions are, let's first zoom in on a classic problem that I am almost certain you've run into before.
Let's talk about a textbook example of a bad code structure, the telescoping constructor. Just imagine a simple user class, right? First, you need a way to create a user with just a name. Okay, then you need another one for a name and an age, and then another for a name, age, and phone number. Before you know it, you have this massive, unreadable, just messy block of constructors. It's a total mess and a huge red flag that something is structurally wrong.
Okay, so how do we actually fix that? Well, our first set of tools is all about making the whole process of creating objects way simpler. Let's talk about factories.
So the big problem that factories are designed to solve is something called tight coupling. It's what happens when you sprinkle the new keyword all over your code to create specific objects. It feels easy at first, but it makes your code super brittle. If you ever need to change one of those classes, you suddenly have to hunt it down and make changes in a dozen different places. It's not flexible at all.
And this is where the factory method pattern is just brilliant. Think about it like a pizza shop. When you walk in, you just ask for a pizza. You don't need to know the recipe or how to work the oven. The shop, that's our factory, handles all the logic of whether it should whip up a cheese pizza or a veggie pizza. Your code is completely separated from the nitty-gritty creation process.
Okay, now let's level that up with the abstract factory. This one is more like ordering a full meal combo. If you ask for a veg meal, you don't just get one thing. You get a whole family of items that are guaranteed to go together. A veg burger, some veg fries, a veg-friendly drink. The factory's job is to make sure the entire set is compatible.
So breaking this down really shows you the key differences. Just look at the scope. A factory method is focused on creating one single type of product. But the abstract factory? It's more complex. It's about creating entire families of related products, like, say, a whole UI toolkit for Windows versus a completely different one for a Mac.
And here's a super valuable takeaway, especially if you're prepping for interviews. The simplest way to remember the difference is this. Factory method creates one thing. Abstract factory creates a whole kit of related things. Getting that distinction right sounds simple, but trust me, it's super powerful.
All right, so factories are amazing for deciding which object to create. But what about controlling how a single really complex object gets put together piece by piece? For that, we need a totally different tool. Let's talk about the builder pattern.
The builder pattern is all about tackling complexity by just breaking it down into simple steps. It very cleanly separates the step-by-step process of building an object from the final object itself. And guess what? This is the direct, elegant solution to that telescoping constructor nightmare we were just talking about.
And the process itself is just so clean. First, you start the builder with only the parameters that are absolutely required. Then, you just chain together these simple method calls to set any of the optional stuff you need. And then, when you're all done, you call build, and boom, you get your fully constructed, ready-to-go object.
And just look at how clean the result is. This is what developers call a fluent API, because it reads almost like a natural sentence. I mean, come on, compare this to a constructor with 5, 6, or 7 confusing parameters.
The difference in clarity is just night and day. It's practically self-documenting code.
Okay, so we've been really focused on creating objects. Let's switch gears and pivot to an equally important challenge: how objects talk to each other. We're going to shift from creational patterns to behavioral ones to answer a big question. How do we let objects communicate without getting all tangled up together?
So here's another problem I bet you've seen. One object state changes, and suddenly you have to go on a treasure hunt through your code to find and manually update 10 other objects that depend on it. This creates a really fragile, tightly coupled system where one tiny change can cause all these unpredictable ripple effects.
The observer pattern totally solves this with a simple subscription model. You have one main object, let's call it the publisher, that holds some important state. Then, other objects, the subscribers, can just register their interest in that state. Now, whenever the publisher changes, it automatically notifies all its subscribers. No more manual updates. This is the fundamental idea behind pretty much all modern reactive programming and the frameworks we use every day.
Okay, here's another fantastic interview tip for you. A really common follow-up question is about the difference between the observer pattern and a general publish-subscribe system. And the key is this. In the classic observer pattern, the publisher knows about its subscribers directly. A pub subsystem takes it a step further and is even more decoupled by using a middleman, like a message broker, so the publisher and subscriber never even have to know that the other exists. All right, so we've looked at factories, we've looked at builders, and we've looked at observers. We've got our toolkit. Now comes the most important part, knowing which tool to pull out of the box for which job.
Think of this slide as your personal cheat sheet for these creational patterns. See, a factory method is all about delegating who makes the object. An abstract factory is about making sure a whole set of objects are consistent. And the builder? That's your go-to for handling a really complex step-by-step construction process. It's never about which one is best, it's always about which one is right for the specific problem you're trying to solve.
So let's just boil this all down to its absolute essence. You're going to use a factory when the main problem is deciding which class you need to create. You'll use a builder when the complexity is all about how a single object gets put together. And you'll use an observer whenever you need to shout out that something has changed to anyone who's listening, without creating a tangled mess.
Woo! We've covered a lot, but honestly, we've only just scratched the surface. The thing to remember is that these patterns are not just some academic ideas. They are practical, incredibly powerful tools for your everyday coding. So really, the only question left is, now that you have the blueprints, what tangled mess of code are you going to go fix first?